Hello viewers, during our previous discussion, we talked about two major components of multimedia, that is text and images. And now it's time that we shift gears and start discussing about sound. Sound is perhaps the most sensuous element of multimedia. It is meaningful speech in any language, from a whisper to a scream. How you use the power of sound can make the difference between an ordinary multimedia presentation and a professionally spectacular one. The motive of this discussion would be to enlighten the viewer with the components and measurements of sound, use digital audio to record, process and edit sound, use MIDI and understand its attributes, and finally compare and contrast the use of MIDI and digitized audio in a multimedia production. The power of sound. When something vibrates in the air by moving back and forth, such as the cone of a speaker, it creates waves of pressure. These waves spread like the ripples from a pebble tossed into a still pool. And when they reach your eardrums, you experience the change of pressure or vibrations as sound. In air, the ripples propagate at about 1200 kilometers per hour. Many sound waves mixed together form an audio sea of symphonic music, speech, or just plain noise. Acoustics is the branch of physics that studies sound. Sound pressure levels, that is loudness or volume, are measured in decibels. The decibel scale with some examples is as shown. This would give you some idea about how sound is represented in decibels, and also notice the relationship between power, which is measured in watts, and decibels. Digital audio. Digital audio is created when you represent the characteristics of a sound wave using numbers, a process referred to as digitizing. You can digitize sound from a microphone, a synthesizer, existing recordings, live radio, and television broadcasts. In fact, you can digitize sounds from any natural or pre-recorded source. The quality of this digital recording depends upon how often the samples are taken and how many numbers are used to represent the value of each sample. The more often you take a sample and the more data you store about that sample, the finer the resolution and quality of the captured sound when it is played back. Since the quality of your audio is based on the quality of your recording and not the device on which you play it, digital audio is said to be device independent. The three sampling rates most often used in multimedia are 44.1 kHz, 22.05 kHz and 11.025 kHz. Sample sizes are either 8 bits or 16 bits. The larger the sample size, the more accurately the data will describe the recorded sound. As you can see in the figure, slices of analog waveforms are sampled at various frequencies, and each discrete sample is then stored either as 8 bits or 16 bits of data. The value of each sample is rounded off to the nearest integer, and if the amplitude is greater than the intervals available, clipping of the top and bottom of the wave occurs. This process is called quantization and can sometimes produce an unwanted background hissing noise, and clipping may severely distort the sound. Making digital audio files is fairly straightforward on most computers. If you want to digitize archived analog source materials, simply plug the line out or headphone jack of the device into the line in jack on your computer. Then use audio digitizing software such as Audacity to do the work. You should focus on two crucial aspects of preparing digital audio files. The first is balancing sound quality against file size, and the second is to set up proper recording levels to get a good clean recording. Higher quality usually means larger files requiring longer download time on the internet and more storage space on a CD or DVD. A distorted recording sounds terrible. If the signal you feed into your computer is too hot to handle, the result will be an unpleasant crackling or background ripping noise. Conversely, recordings that are made at too low a level are often unusable because the amount of sound recorded does not sufficiently exceed the residual noise level of the recording process itself. The trick is to set the right levels when you record. Any good piece of digital audio recording and editing software will display digital meters to let you know how loud your sound is. Watch the meters closely during recording and you will never have a problem. Unlike analog meters that usually have a zero setting somewhere in the middle and extend into ranges like +5, +8 or even higher, digital meters peak out. To avoid distortion, do not cross over this limit. If this happens, lower your volume either by lowering the input level of the recording device or the output level of your source and try again. Try to keep peak levels between -3 and -10. Anytime you go over the peak, whether you can hear it or not, you introduce distortion into the recording. In digital meter displays, if you see red, you are over the peak. Once a recording has been made, it needs to be edited. Audacity is a free open source sound editing application for Windows, Macintosh and Linux. With such a tool, you can create soundtracks and digital mixes. In the following discussion, we will talk about the basic sound editing operations that most multimedia producers need to know. Trimming. Removing dead air or blank space from the front of a recording is your first sound editing task. Trimming even a few seconds here and there might make a big difference in your file size. Trimming is typically accomplished by dragging the mouse cursor over a graphic representation of your recording and choosing a menu command such as cut, clear, erase or silence. Splicing and assembly. Using the same tools mentioned for trimming, you probably want to remove the extra noises that inevitably creep into a recording. Even the most controlled studio voiceovers require touch-up. Also, you may need to assemble longer recordings by cutting and pasting together many short ones. In the old days, this was done by splicing and assembling actual pieces of magnetic tape. Volume adjustments. If you are trying to assemble 10 different recordings into a single soundtrack, there is little chance that all the segments will have the same volume. To provide a consistent volume level, select all the data in the file and raise or lower the overall volume by a certain amount. Don't increase the volume too much or you may distort the file. It is best to use a sound editor to normalize the assembled audio file to a particular level, say 80% to 90% of maximum without clipping. Figure shows the normalizing process at work in Adobe's sound booth. Format conversion. In some cases, your digital audio editing software might read a format different from that read by your presentation or authoring program. Most editing softwares will save files in your choice of formats, most of which can be read and imported by multimedia authoring systems. Fade-ins and fade-outs. Most programs offer enveloping capability. useful for long sections that you wish to fade in or fade out gradually. This enveloping helps to smooth out the very beginning and the very end of a sound file. Equalization. Some programs offer digital equalization capabilities that allow you to modify a recording frequency content so that it sounds brighter or darker. Time stretching. Advanced programs let you alter the length of a sound file without changing its pitch. This feature can be very useful, but watch out, most time stretching algorithms will severely degrade the audio quality of the file if the length is altered more than a few percent in either direction. MIDI audio. MIDI, known as Musical Instrument Digital Interface, is a communication standard developed in the early 1980s for electronic musical instruments and computers. It allows music and sound synthesizers from different manufacturers to communicate with each other by sending messages along cables connected to the devices. MIDI provides a protocol for passing detailed description of a musical score, such as the notes, the sequence of notes, and the instrument that will play these notes. But MIDI data is not a digitized sound. It is a shorthand, a representation of music stored in numeric form. Digital audio is a recording, MIDI is a score. The first depends on the capabilities of your sound system, the other on the quality of your musical instruments and the capabilities of your sound system. A MIDI file is a list of time-stamped commands that are recordings of musical actions, such as the pressing down of a piano key. When sent to a MIDI playback device, this results in sound. A concise MIDI message can cause a complex sound or sequence of sounds to play on an instrument or synthesizer. So, MIDI files tend to be significantly smaller than equivalent digitized waveform files. Composing your own original score can be one of the most creative and rewarding aspects of building a multimedia project, and MIDI is the quickest, easiest and most flexible tool for this task. Yet creating an original MIDI score is hard work. Knowing something about music, being able to play a keyboard and having a lot of good ideas are just the prerequisites of building a good score. Beyond that, it takes time and musical skill to work with MIDI. To make MIDI scores, you will need notation software such as Sibelius, sequencer software such as Pro Tools, and a sound synthesizer, which usually is built into the software of multimedia players in many computers and many handheld devices. A MIDI keyboard is also useful for simplifying the creation of musical scores. Rather than recording the sound of a note, MIDI software creates data about each note and is played on a MIDI keyboard. The example for the data could be how much pressure was used on the keyboard to play the note, which note it is, how long it was sustained, and how long it takes for the note to decay or fade away. This information, when played through a MIDI device, allows the note to be represented exactly. Because the quality of the playback depends upon the end user's MIDI device rather than the recording, MIDI is device dependent. The sequencer software quantizes your score to adjust for timing inconsistencies, and it may also print a neatly penned copy of your score to paper. An advantage of structured data such as MIDI is the ease with which you can edit the data. Let's say you have a piece of music being played on a piano, but your client decides he wants the sound of a saxophone instead. If you had the music in digitized audio, you would have to re-record and re-digitize the music. When it is in MIDI data, however, there is a value that designates the instrument to be used for playing back the music. To change instruments, you just change the value. Instruments that you can synthesize are identified by a general MIDI numbering system that ranges from 0 to 127, and some of these numbers are shown in the picture. Since MIDI is device dependent and the quality of consumer MIDI playback hardware varies greatly, MIDI's true place in multimedia may be as a production tool rather than a delivery medium. MIDI is by far the best way to create original music, so use MIDI to get the flexibility and the creativity. Then once your music is completed and fits your project, lock it down for the delivery by turning it into digital audio data. MIDI versus digital audio. In contrast to MIDI data, digital audio data is the actual representation of a sound stored in the form of thousands of individual numbers or samples. The digital data represents the instantaneous amplitude or loudness of a sound at discrete slices of time. MIDI data is device dependent, digital data is not. Just as the appearance of vector graphics differs depending on the printer device or display screen, the sounds produced by MIDI music files depend on the particular MIDI device used for playback. The MIDI standard lets instruments communicate in a well understood language. MIDI has several advantages over digital audio and two huge disadvantages. First, we will talk about the advantages. MIDI files are much more compact than digital audio files, and the size of a MIDI file is completely independent of playback quality. Because MIDI files are small, they don't take up as much memory, disk space or bandwidth. Because they are small, MIDI files embedded in a web page load and play more quickly rather than digital equivalents. In some cases, if the MIDI sound source you are using is of high quality, MIDI files may sound better than digital audio files. You can change the length of a MIDI file by varying its tempo without changing the pitch of the music or degrading the audio quality. MIDI data is completely editable right down to the level of an individual note. You can manipulate the smallest detail of a MIDI composition in many ways that are impossible with digital audio. Because they represent the pitch and length of notes, MIDI files can generally be converted to musical notations and vice versa. This is useful when you need a printed score. In reverse, you can scan a printed score and convert it to MIDI for tweaking and editing. Now for MIDI's disadvantages. Because MIDI data does not represent sound but musical instruments, you can be certain that playback will be accurate only if the MIDI playback device is identical to the device used for production. Even with the general MIDI standard, the sound of a MIDI instrument varies according to the electronics of the playback device and the sound generation method it uses. Also, MIDI cannot easily be used to play back spoken dialogue, although expensive and technically tricky digital samplers are available. When to use MIDI? Digital audio won't work because you don't have enough memory or bandwidth. You have a high quality MIDI sound source. You have a complete control over the machines on which your program will be delivered. So you know that your users will have high quality MIDI playback hardware. You don't need spoken dialogue. The most important advantage of digital audio is its consistent playback quality, but this is where MIDI is the least reliable. With digital audio, you can be more confident that the audio track for your multimedia project will sound as good in the end as it did in the beginning when you created it. For this reason, it's no surprise that digital audio is used far more frequently than MIDI data for multimedia sound delivery. So lastly, we'll talk when to use digital audio. When you don't have control over the playback hardware, you can use digital audio. When you have the computing resources and bandwidth to handle digital files, you can use digital audio. And lastly, when you have spoken dialogues, you must use digital audio. So friends, this brings us to the end of this discussion, and in this lecture we learnt about digital audio and the process involved in its recording and editing. Then we discussed the use of MIDI and understand its attributes, and finally compared the use of MIDI and digital audio in a multimedia production. So that's it for today. See you in the next lecture on multimedia system sounds. Thank you very much.